Welcome back to this tutorial on data science for human resource project based. And in this tutorial, previously we were looking at a given data set from a department of human resource in a business. And this data set contained information about employees who are with the company and employees who have left the company. Each of the employees or each of the data sets has got different attributes, and one of the most important attributes that were loaded on this data set are satisfaction level, last evaluation score, that is how much they scored based on the evaluation that was performed by the company. The second one was the number of projects that they were involved in. The fourth one was average monthly hours. The fifth one was time spent in the company. The sixth one was whether the employee was involved in an accident or not. And then the sixth one was the department that the employee was working before they left. And the last one was the categorization of the salary in terms of low, medium, and high. So the whole idea of this human resource project was to answer two business questions, which is normally the issue in data science. Sometimes you answer the business question, sometimes it's a research question. But in our case, it's a business question, and the two business questions were what type of employees are leaving and which employees are likely to leave next. So that was the project for this project, was the overall objective of the project, sorry. So before we proceed, I will ask you to kindly subscribe if you have not subscribed. Share this video. It might be informative for people who are into business or people who are into data science, looking for real applications. And this is first out of many series that I will be providing on this platform on real data science projects with real data. So in this last section, we want to do or perform the comparative analysis to give us insights on the type of employees that are leaving. And in this section, we are going to focus more on visualization as a means of learning the story that the data is telling us. So as you remember, if you haven't downloaded the file, I've posted the link for the data that is used in this tutorial. If you are new, this is your first video that you are watching, please make sure that you go back and watch the last two videos. They are very, very important on providing the background and the kind of flow work or workflow that you have been doing for the last two videos. So in this last section, basically, we are going to compare now the employees by the attributes and see if there's any kind of information that we can get about the types of employees that are leaving. So initially, you don't need to do this if you had done it before, but initially we had got two data frames, one for the existing employees. So I'm just gonna copy this and run it again. So this one is for the existing employees, the ones that are leaving. And just a little bit of the code or background. We are creating a new data frame called DF. And this data frame is created by reading raw data from an Excel file called employeesdata.slx, which is the extension file for Excel. So this is the data that you need to download. If you haven't downloaded it, that's okay. You can download it. I've posted the link on the description. If you have downloaded it or you did in the previous section, you don't need to do it again. And then this is the sheet number or the sheet name of that file. So the whole file is employees data, which is this name here. This is the name of the file, and then the sheet name is existing employees. So once we do that, we just read the first few columns to see if it's working. Of course, you don't need to do this again. And we also imported another data set as df1, but this time we are concerned about employees who are not leaving, but the employees who are existing. So this, sorry, I interchanged them, but yes, this is the employees who are existing. So this should be existing employees. So these are the two data sets that you need. But for us, let's concentrate on the employees who have exited, because that is our main focus. We want to know the patterns and the properties of these employees. So as is the custom, we start from where we stopped. There's no need for doing exploration because we did that in our previous sections. And now in this section is all about comparisons and learning the features of these employees that have already left. So we realize that there are very, very important attributes when it comes to this data set. One of those important attributes are satisfaction level, how well the employees were satisfied with the company, the scores during the last evaluation, the number of projects they were involved in, average monthly hours, time spent, and from our previous section, we say that we don't need to focus on the work accident and promotion for the last 5 years, and we explained that. So our key concern will be these other attributes, or these other features of the data set. So the first thing we need to do is to group each of these employees based on those features. The first thing that we want to do as far as that is concerned is to group them based on the last evaluation score. And then we're going to do the same for the number of projects. We do the same for average monthly hours, and then the time spent, and so on. So we do that using the group by function. Group by function is very, very important in Pandas for data science because it allows you to obtain unique characteristics of data and learn the patterns within the data by just taking a comparison analysis of the data. So let's focus first of all with let me just remove this one for now. I do not need this cell for now. We'll have it later. So let's focus on the last evaluation. So to do that, create a temporary data frame called df evaluation. And then we're going to group the last evaluation score based on the scores. We're going to group them, the number of employees based on the scores. First of all, let's know how many employees we have, just as a reminder. And do shape. We see that the employees that have left are 3,571. So we're going to group these 3,571 employees based on their evaluation score and see which employees have left and what was their evaluation score. So to do that, we just use the original data frame, which is df, this data frame here that contains everything. And then we do group by function. And then select the column we are interested in. So we are interested in the last evaluation. I always advise you to copy it directly so that you avoid issues of white spaces within your data set. And then we want the size of the employees based on the evaluation score. And then I want us to reset the index so that we don't run into issues with columns not matching. And then I want us to classify these employees based on the scores and create a new column that aggregates. So what I'm saying is, this one might not be good to show an example, but let me give you an example with the time spent. So you see the time spent by the companies, by the employees in the company can either be 3, 6, 4, 5, or 3. So what we are doing in this section is to classify the employees, or group the employees by the time spent. So you might find that out of the 3,571 employees, only maybe 500 spent 3 hours. So those 500, we're going to name them as a number. So that's a numeric. That's why I'm creating a new column here to store that numeric or the summation by group types as numbers. So once we do this, we can run to see the results of our group by function. So let's do that. Good. So you can see it has grouped this by the scores for each of the individuals, and it has returned the corresponding numbers. So we have got the individual who scored 0.45, there were 65. Those who scored 0.46, there were 162, 0.47, 113, like that. So that is a good way to have it. So instead of displaying all of this, we can just do dot head to make sure that we just display the first few values, as you can see. So that is to do with evaluation score. We can plot this data so that because numbers, it's very hard to imagine numbers from the top of your head. So the best thing is to visualize it, because visualizations, as they always say, a picture is worth 1,000 words. So let's use the matplotlib function to do this. And the first thing we need to do is, so we already imported matplotlib here. Import matplotlib.pyplot as plt. So we are going to use the functionality to plot our data and have a comparative analysis based on the evaluation scores of each of the individual people. I'm suspecting this data is going to, or the visualization is going to be scary because we have lots of categories, but nevertheless, it will make more sense as we go into the new attributes and you will see what we are trying to do here. So let's create, first of all, the general figure of our plot, the size of our plot, and we do this using the matplotlib function figure, which accepts the argument fig size. And basically here you just define the size of the figure, that is the length and the width. So the length, I want us to have a length of 8 and a width of 5. And then the next thing we do is to label our xplot using the function label. And this accepts the string, so I can say the function is just the number of this evaluation score. And then the y-axis is gonna be using the function label again. It's a string. You can say number of living employees. So essentially, these numbers is what we are plotting on the y-axis, and the evaluation score, which in this case can be thought of as categorical data, though it's not categorical, but it's categorical in this sense, to store the type of evaluation score that each of these people scored. And then the x-axis basically is going to take the values that we want to plot on the x-axis. So our x-axis is going to be the evaluation score. So to plot this directly without reading it or the way we are doing it or writing it down in our previous tutorial, we can basically read the column name and the column itself and plot it directly. So to do this, we just use the name of the data frame, which is df evaluation here. Have it over there. And then read the column name, which is our last evaluation. And this will plot our x values. In other words, this value is 0.45, 0.46 until the last one. Same for the y-axis. It's going to be the same thing. We copy now the numbers. We are interested in the numbers. And once we do that, the next thing is to plot it as a bar graph, because this is a comparative analysis. So bar graphs are super useful for comparative analysis. So I'm going to do plot bar, which is a function in matplotlib that allows us to plot data in terms of bars. And it accepts the x and y, which we have already defined as the two column names. And then we can plot this for a while and see how it looks like. So sorry, this one should have been y. Made that mistake. So you can see this is a bar, not one of the nicest looking bars, very ugly, but we'll do the next one. It will make more sense. So we can add other aesthetics on this bar, like the grids, so that it has got kind of your bar graph, the ones you have on your books. So let's add that using the function grid. This is just to make it nice. It's not necessary, but it's making nice, given that you're going to show this to your bosses. So the grids we want the grids both on the y and x axis. And then the line style, we're gonna have it as a full colon. You will see why. I'll vary that. And then of course you can save this plot automatically in your working folder using the function .savefig and give it a name. I'll give it a name project, we'll give it a name, evaluation score, and you can either choose it to be a .jpg or PNG. I'll use JPG. And then you can specify the resolution. In this case, I will not be very ambitious. I'll save it at 300. And then you can see the graph is a bit prettier. There's the grids on both axes and the style is dotted. You can also have got dash like this. And you can see it's very much bold. So that's why I kind of opted for this one. So that is to plot and do the comparative analysis of the employees based on the evaluation score. It's very, very hard to read this because it's a continuous plot. A lot of variables from 0.45 to 10. So you expect a lot of variables within that point. Let's solve this problem by using a more discrete one, specifically the number of projects, because you realize that the number of projects only ranges from 2 to, I think, 7. Yeah, 2 to 7. So now let's do a comparison and see how many employees have left this company based on the number of projects. So the syntax is the same. Just copy the whole of this, but let's not copy. Let's just type it so that you get a good understanding. So df dot, let's give it a name. So we are focusing on project number. So I'll say df number project to give it a name. And as is the custom, we literally use the same approach as we were doing. So nothing has changed. Very straightforward. I'm interested in the data frame itself, then group by. And then the column of interest is this number of projects. I'm just copying it to avoid white spaces. And then I want to group them or sum each of the individual options within that. And then reset the index. So reset index. And then the name, I want the total numbers, so I'll just say numbers, so that's the new column. And then let me read it. Okay. It's supposed to be number. So once I run this, you can see that it has given me results of the employees who have left the company based on the number of projects they worked on. So out of the employees who have left, 1,567 of them only worked on 2 projects during their period. And then only 72 worked on 3 projects. Only 409 worked on 4 projects. So clearly, the employees who are leaving are those who worked on the least number of projects. Majority of them, 1,567, only worked on 2 projects. So this could be a possible reason why they are left. Maybe they are not being involved in many projects. Having these numbers as this is demanding. We can literally do another plot for this. It's supposed to be Control-Z. Do another plot for this by just copying our previous syntax and changing the values here. So you see, this one remains the same. The plot label or the x-axis, we can basically have it as the number of employees, number of projects, because we are doing this, number of projects. And then the y-axis will be the number of exiting employees. And of course, this one is the number of projects, so copy that one directly. It's the column name for a new data frame. And then number stays the same, but the data frame is not df evaluation, the data frame is df number project. So once we do this, let's run it and see the results we have. This is nice, interesting results. It's very easy to see from just looking straight. You can see that now the bars gives you a very good visualization in terms of knowing by just looking without digging deep into the numbers itself. You can see that the highest number of employees who have left had only 2 projects, and those who had 3 projects only around 72. Although you can't have the numbers, but it gives you a general picture of the type of employees who have left by the project they were involved in. So we can do this for the rest of the columns, but that will be a stupid thing to do, especially when you are programming, because as I always say, if you're doing something more than 4 times in a programming language, then probably you need to do a loop. So to do the loop to plot these graphs automatically is a little bit demanding, but let's do it so that maybe you can use the same in your subsequent projects, or just use the same syntax in the subsequent projects. So what we need to do is, first of all, create all these attributes as data frame. So we have already created one, the one called DF evaluation. We have created the second one, number of projects. So allow me to copy them and have them in just one cell so that you see what I'm doing, and also copy the one for number of projects. So the next one, we are interested in also classifying the exiting employees by the average monthly hours. We will do the same for the time spent, and then I want us to do for department and salary. So let's do that. The syntax is pretty much the same, df number. So this time now we are using monthly hours, and use the same syntax, group by. The only thing that is changing is the column name, monthly hours. We copy that directly, and then do size. Then we reset the index, and then name, we give that new column, numbers. So that's it. Let's do the same for the next attribute which we are interested in, is time spent in the company. So time spent as the new data frame, then do group by the original one by that column name, which is time spent. Then we do size, reset the index, the name, simple, just numbers. By the way, you can have anything here, it's just the column name that we are assigning the new one. I think that will be monotonous. We can just copy now that you know the syntax, what we are doing, and then change the next one, which I think is the department. So the new column is department, and then copy the column name, the next one is, let me copy this again. We don't need to retype everything every now and then. Now that you know how to do it, we classify them by salary to see what the range, or what the size, what is the salary of the employees who have left. Let's see how the column is named and copy it directly. It's called salary, straightforward. Numbers. So now we have got all these attributes made as numbers. So I can see we are having an error on monthly hours. Okay, the spelling is wrong. It's supposed to be group by. I omitted B. Group by. I hope it's correct now. Yes. Now that we have got these data frames that are based on different attributes, we can create them as a list. So let's create a list called attributes, and it's gonna hold each of these data frames. And then we're gonna loop through this list to create plots every time we run the loop. So this list is gonna contain all the data frames, and then we're gonna loop through the list and create plots from every time we run that loop. So now you realize that whatever you were learning in our previous introduction to Python tutorial are now becoming useful, because now we can write loops and loop through our data set to perform tasks automatically without repeating ourselves now and again. As I always say, if you are doing something more than 4 times in a programming language, then probably there's a loop somewhere that you need to write. So when we loop through this list, we can just do for attribute in attributes. So these are the attributes of our data set. Let's just first of all make sure that the loop is working and print each one of them. So I can just say print. So you can see it's printing attribute in each one of them, which is good. I mean, it's supposed to print attribute, not attributes. So it's printing each of the data frames that we have here. Okay, this is now interesting. Now, we can, as you know, we can literally read the columns for each of these data frames from this loop by just specifying the column name or the location of the column. So for example, if I want to print df evaluation before the attribute, before the loop, I can just do df, let me copy it, then like this, bear with me. Then I read the column, the first one. So the first column of df evaluation is this one that contains the scores. So I can do that using 0, which is the first one. And you can see it returns all the scores. If I do 1, it returns the total numbers. I can do the same for number of projects by just changing the data frame name. And you can see it returns this. So this is going to be important because I want to plot these graphs individually. Every time I run the loop, it plots the graphs for each of these 4 or each of these 6 attributes and have our graphs generated automatically. So how do we do that? Basically, we are going to insert the whole of this code inside this loop. And every time we run it, it's going to create these similar graphs, but for each of the attributes. So it's going to create a total of 6 graphs, 1 for number of evaluation, number of projects, monthly hours, time spent, department, and salary. Let's do that. So allow me to copy this, or to be on the safe side, let's rewrite it again, because now we are writing it inside a loop. So the first thing we need to do is just to have our figure size. So I'm going to do plot figure and specify the fig size, which is like the dimensions of our plot, fig size. This is going to be I want us to have more smaller plots. So let's have 6 by 5. That should be fine. And then the X label, the label of the X-axis is going to be the first column of each of the data frames that we have created. And I've shown you how to access those data frames. So what we need to do is to, let's have an example of one of those ones that we have created. So for example, let me delete this. We have got this data frame inside our list that contains project number. So the project number has got 2 columns. The first column is number project. The second one is numbers that we created when we were grouping them here. So to access this first column, we simply type the name of this data frame and specify the column, use the function columns, and we can use the square bracket of 0 to show us that the first column or column in position 0. As you know, computers start numbering from 0. So if I do that, it will return all values that are under project name. If I do the same, it's going to return all values that are under numbers. So that is the whole idea of doing this. So now, to label the access, we basically want our code to use this name here to label it. So if you know that this is a string, so it's going to read the data frame, look at the column name, and then use it as a string. So convert it as a string. So to do that, we use the function str. Python has a function str that convert data points or convert any kind of data into a string, even if it's a number. In other words, if I have got this number as 5 here, this is an integer. But if I do str to 5, it converts it into a string, even though we know that 5 is an integer. So now it's a string and it's not a number. So that is the same concept we are using here. It's going to take the column name and convert it as a string and use it as our X label for the plot. So I'm going to do str. And every time it does this, it checks on the attribute. And remember, attribute here is each of these each of these data frames that we have inserted in our list called attributes. So it's gonna read the attribute and focus on the first column, which is normally the one that contains the name of the attribute that we are interested in. And we go for the first one, which is 0, and that is this column here, number of projects. So that will be on the x-axis. Now, for the y-axis, it's going to be the numbers, this column here. So you can guess it's going to be exactly the same as this, but now instead of 0, it's 1. So it's position 1. So let's do y label str, and then let's just copy this. But now we are focused on the second one, which occupies position 1 as per the computer numbering. And then we can have the title, which is, we'll just say exiting employees by, let's add a string. So we're going to add just, I'll say, let's not complicate it. Let me just do by exiting employees. Okay, so that is going to be the title. And then the x-axis is going to be straightforward. Is the data frame itself, which here is the attribute. And then dot square bracket, have attribute there, dot column square bracket 0, and repeat the same for y, except that now instead of 0 it's gonna be position 1. This is gonna be position 1, and it's y. And then we plot plt.bar x, y. So we are putting x against y, or y against x, sorry. And then we can add the aesthetics here. And then run. So once we run this, it's going to plot all the plots, starting with the evaluation, number of projects, monthly hours, time spent, department, and salary. So let's do that. So attributes.columns, it's throwing an error on the X label. So let's see where the error is coming from. str. Let me hash it out first to see if it's gonna run. Okay, so this now makes sense. Let's debug it. This is now it gets interesting. Attribute in attributes. I think we never ran this, so let me run it again. It should work. Yeah. So the issue was I didn't rerun the list when I changed the name. So now you can see it is returning all the plots. So starting with exiting employees, and then number of projects, and then average monthly hours, time spent, department, not an ugly plot because it's smaller in size. I think we can increase, and then salaries. So we can increase the size so that it captures all the column names neatly. Let me change that to 10. At least now the column is spread but still lacking some kind of aesthetics. We can plot that individually, but now the whole idea is to compare the employees that are leaving based on the characteristics. So if you look at exiting employees by the number of projects, we can clearly see that employees with small number of projects, the maximum, most of them were leaving, that is around 1,500, and those with 3 projects were the least. When you come to average monthly hours, this is not a nice plot. We are going to do something about this plot in the next section because you can realize that there's so many variables. So it will be better to use a different kind of plot. Same to the evaluation score. When it comes to the time spent in the company, most employees who have left have spent an average of 3 years in the company. So the reason for this is something that the HR can say, or the subject matter experts can explain why this is happening. And then in terms of department, you realize that the employees who are leaving, majority of them are from the sales and technical and support department. And this kind of makes sense because if you look at most organizations, these are the people that does the bulk of the work, and they are likely to leave maybe in search of better salaries or in search of more promising jobs or more or less stressful jobs. If you look at the company again, the least number of people who are leaving are the management, which makes sense. Maybe they have little job, or their work is not as demanding as possible. I don't know. I'm not an HR expert, but you can see the story that the data is telling you. Also, the research and development team, very few of them are leaving. The reason for that is beyond my pay grade. When it comes to salary, you realize that majority of employees who are leaving is because they have the low salary. So this tells you something about these exiting employees. So therefore, you can confidently approach the person or the boss who assigned you this task to explain to them that from my analysis, I can tell that our employees who are leaving are likely to come from the sales, support, and technical department. So those should be your focus areas. How do you make sure that employees from those departments doesn't leave? Secondly, our employees who are likely to leave have low salary. So you need to do something about the salaries so that we can reduce the number of employees leaving based on the salary. Or you can check on the time spent with the company. Majority of our employees who have left are those employees who are in their 3rd year. In the 2nd year is the least, and this is interesting. Maybe these employees have just come into the company, things are not working, but they're thinking that, okay, maybe things will get better, so let me stay. Or it could be that these are new or entry-level employees. They're just staying there to look for experience, and once they get into their 3rd year, they are likely to leave. So those are the kind of the story that the data is telling you. Now, if you look at the data on the average monthly hours, you realize that there's a lot of variation, and this is not interesting, and it's not easy to understand from looking at this. So the best way to probably visualize this data is to use histograms, where we group these employees based on the average monthly hours. And as you know, we had done this previously in our previous section. We can simply use the seaborn function distribution plot that plots these variables based on the column that we are given. So here we are interested in average monthly hours. So we just use the seaborn plot. It has a function called distribution plot, df, and then have the average monthly hours as the column of interest. And specify the KDE as true, and then group them. Let's use 8 groups. Run and see what we have. So you can see now this is the distribution plot. This is much better than this. It's very hard to see. So here we can confidently say that the highest number of employees who have left the company are those employees that worked for an average monthly hours of 125 to 150. And also those who worked at an average number of hours from 250 to 275 here. So this is a very good way to visualize this data set. The same goes to this one by evaluation score. So we can do the same. Let's do a distribution plot for the evaluation score by just copying this plot, but changing the column name to evaluation score. Let me copy the column name directly so that I don't run into issues of white spaces. So let's see the distribution. So interestingly, the distribution is the same as average monthly hours. So we can see that most of the employees who have left had an average monthly score of just slightly above 0.5. And the least ones are those who had an evaluation score of 0.7. And this probably will be that maybe they scored 0.7, then they were retained, or maybe the salary was increased. And then also significantly, those who have scored higher evaluation score like 0.9 and 1 are leaving. Probably now they have realized that they're way much better. Maybe they have outgrown the company, so they're looking for new opportunities. So that is something that now is of much interest to us. So now, remember the last question, or the question is, what kind of employees are likely to leave? So now that we have compared this based on the type or the attributes, we can plot this as a percentage of the maximum number of employees. In other words, we're going to look at something like number of projects. We can see that the maximum number of employees who have left based on the number of projects is 1,567. So we can use this, we can calculate this as a percentage of the total employees who have left the company. To know the total number of employees who have left the company, you just need to check on the data or the shape of their data frame. So if you look at the shape of the data frame, it tells you that the data points are 3,571. So in other words, 3,571 employees left the company. And out of those 3,571 employees who have left the company, going by this new classification or new analysis, we can see that 1,567 of those employees only spent 2 projects, or only did 2 projects. So we can calculate this as a percentage of the total exiting employees by simply dividing this number by this number. And then we calculate the percentage to see how employees are leaving based on this attribute. So we're going to do the same thing, write the same functionality of the plot, or write the plot as we did here. So let me just copy this. I don't need to rewrite it again. But this time round, we are not just plotting the numbers, but we are plotting the maximum value divided by the total value of the existing employees so that we can do the comparative analysis. So it doesn't make sense, but as we do it, you're going to understand it. So the first thing is calculate the total exiting employees. How do we calculate that? As I said, you just need to look at the shape of the data frame. So df dot shape, and this one is interesting. It just tells you that 3,571 people have left the company. So remember, this is a tuple. It tells you that 3,571 employees left the company, and only 10 is the attribute. So these are different attributes. So we are only interested in the first one, which is 3,571. So let's use that value, 71. And now we want to calculate that as a percentage. And then the next thing we do is to calculate the maximum number of employees in each category. So in other words, if we come to employees living by the evaluation score, we are only interested in the maximum number. When it comes to those living by the number of projects, we will be interested in only 2 because this is the maximum. This one is hard to tell. When it comes to employees living by the time spent in the company, we'll only pick 3 because these has got the maximum number of employees. When it comes to by department, we only pick sales. And then by exiting employees, we only pick low. So to do that, we're just going to use the same approach. Specify the column or the data frame, and then the columns, the data frame. Let me just make sure that the same, to make it easier, let me copy this. But we are interested in the number column. And then here we simply find the maximum value using the max function in pandas. And this is the high number or the highest number for each category. And then this number, we divide it by the total existing number and then multiply by 100 to get the answer into percentage. So to calculate percentage, we're simply going to divide the total or the maximum number in each category, which is already given as high. Then we divide it by the total existing employees here. And if we do that, it's going to return a very huge number. So let me just run this and then let's see. So there's something I want us to do. So here where we are writing numbers, we can actually specify the names instead of just having numbers so that we have got different values. So like here, I can say evaluation score. Here I can say projects. Here I can say monthly hours so that they are a bit different. Here I can say time spent. Here department. Here salary. So if you do like this, please, if you are making changes here, make sure that in case you run into problem, possibly it could be that you have changed the name. So just make sure that you change anywhere else in your code. Now, the next thing that I'm going to do is I'm going to have the percentage, and then I will get the names of each of these classifications. I'll say name equal to the name of the data frame itself, and then columns, take the first one, which basically returns the column name, So this one. And then the title is gonna be X label. So X label is going to be each of these namings or each of these percentages. And then the last thing that I'm gonna do is to plot them. So now I'm not plotting X and Y, but I'm plotting the names, which is the name of each of the data frame. In other words, these ones that I've just created here. And then I'm gonna have Y, the percentage that I've just calculated here. And then once I do that, I do not need this X and Y. So I can run this code to give me the percentage. There's a problem somewhere. Okay, so I see the problem is on I didn't run the attributes list again, so I need to rerun it to make sure that it's reading from the right list. And then when we come back here, we only need to plot the figure 1, so we can take the figure option outside the loop. And then the next thing is to ensure that we divide our percentages by 100, because we are dividing the highest amount by the total number of people who have left times 100, which is the percentage. And then we label or we get the names of each of these attributes using the data frame name, which is attribute in this case, and only reading the first one. And then once we do this, we can plot, we can run our code. I don't think if we need the X label, because each of the attributes will become automatically the label, so we don't need the X label. And then run this code. So if we do that, you can see we have exiting employees based on the highest amount of score as a percentage of the total number of people leaving. So you can see salary has got the highest percentage. So in other words, salary is a big determinant on these people who are leaving, because the highest percentage of those leaving employees have left based on the salary. We can print the percentages so that we know that this is the values that you're having. So let's just add a print function here. Print str, which is the name of each of these. So it's going to be evaluation score, projects, monthly hours. So let me do that by changing the name into a string. And then I'm going to add it to percentage that we've calculated here as a string. So basically I'm concatenating strings again from our previous Python. And then let's run this to see the percentages. So you can see there is a evaluation score. There's no space between. It looks uglier, so we can add a white space here by just adding this empty quotation marks and then run the code. So I forgot to add the string, so concatenate plus sign to concatenate them. So now we have got a space between them, but then again this number is huge and it's the percentage, so we can basically round this down using the function round, and it accepts the value, which is this whole value here, then comma. I want to round them to two decimal places. Let's run this. Okay, so this looks interesting. So the number of employees who have left as a percentage of the total exiting employees based on the attributes is evaluation score 4.68%. So in other words, evaluation score only contributes 4.6% of the total number of leaving employees. But if you look at the salary, it contributes the highest, so 60%. 60% of the living employees left is based on the salary, and followed by time spent. So time spent is a very determinant factor, or a very huge determinant factor on the employees who are leaving. So the human resource should focus on these numbers to know that salary is going to be very influential on whether they want to retain or keep their employees, followed by the time spent, and then projects, and then time department, and then lastly is going to be the monthly hours, which is the least contribution to whether the employees are going to stay. So this is the numbers based on the exiting employees. So now to answer the third or the last question, or the last business question, which employees are likely to leave next, this gives you a true picture, or a very good picture, that employees with the lowest salary are likely to leave next, and these are 60%. So if you do 60% of the existing employees, so remember, existing employees, we imported that data frame at some point. Let me just run it, look at it somewhere. Yes, so this was the existing data. So these are the existing employees. So we want to know which employees are likely to leave next. Let me do to see how many employees are existing by just using shape. So we have got 11,428. So going by these projections, 60% of this total number, so if I do 60.82 multiply or divide by 100, and then everything here I multiply it by this amount here. So assuming that these values have to stay the same, then the company might lose 6,950 employees based on the number of salary, or the amount of salary they earn in a month. So in other words, this project has allowed us to look at the data to explain or to understand the nature of leaving employees and the employees that are staying within the organization. And this is just one out of many projects that we can learn by looking at the story at which the data is telling us. Again, this is purely for learning purposes. It's always good to look at the other team, or make sure that in your team there's experts or domain experts. So like in this case, you need somebody who has got very good understanding of what influences the employees stay or living in an organization. And then you can run these numbers, and with them they can give you possible reasons, or they can give you explanations on why this is happening. As you can see, we have always been saying causation or correlation is not causation. So the numbers are telling you a story. The story cannot be changed. It's based on the numbers, but you need the domain expert to help you with this explanation. So whatever you have done here, this is what now goes to your report when you're presenting your findings to your boss or to the department that assigned you the task. In most cases, you'll be using these plots that you are making and these short notes that you are taking within your code to write the full report. Again, if you have not subscribed, please make sure that you subscribe, like the video, share with friends who might be interested in this kind of work. And in the next series, we're going to have got more and more of this data science projects, so that you have more understanding on how you can implement them in your day-to-day work life or in your research. So again, thank you very much. Let's meet on the next data science project. Bye for now.